Today we're going to be finding the difference quotient of a function. This can be used to find a tangent to a curve, and also this formula computes the slope of the secant line through 2 points on the graph of f. These are the points with x-coordinates x and x plus h. The formula looks like this. It's the quantity f of x plus h minus f of x over h. This is a difficult formula, but with some practice, it's easy to understand. For our first example, we're going to show how to find the numerator of the formula. So that's the f of x plus h minus f of x. This means that for every x in the original formula, you're going to plug in x plus h. So for f of x plus h will equal 2 x plus h minus 5. Next, the formula says to subtract f of x, which is your original formula. So you have f of x plus h minus f of x equals 2 x plus h minus 5 minus 2x minus 5. Don't forget to put this into parentheses to show that you have to distribute the negative. So you have f of x plus h and f of x. The next part is to distribute. So you're going to distribute the 2, the x, and the h, and the negative to the negative, or to the 2 and the negative 5. So you have 2x plus 2h minus 5 minus 2x plus 5, because it's negative and a negative. The next is to combine like terms. So this means that in this equation, the 2x and the minus 2x can cancel, and the minus 5 and the plus 5 can cancel. So I would say that the numerator in this equation is all that is left is 2h.
Alright, for our next example, we're going to let the function f of x equal 3x plus 2. And this time we're actually going to find the entire difference quotient, which is f of x plus h minus f of x all over h. So what you first want to do is plug in x plus h everywhere you see an x. So what you're first going to do is have 3x plus h plus 2, and then the next part of the formula says to subtract off the original function, which is 3x plus 2, and you're going to want to put parentheses around that again to make sure to later distribute the negative to that whole thing, because that's a common mistake. And you're going to want to put this whole entire thing all over h. The next thing you want to do is distribute the 3 to both the x and the h, and you're going to get 3x plus 3h plus 2 minus 3x minus 2, because you're going to want to distribute that. And you're going to want to put this all over h once again. Now you're going to want to combine like terms or see if you can cancel out anything. And here you're going to be able to cancel out the 3x minus 3x and the positive 2 minus 2. And you're left with 3h all over h. And here you can simply cancel out the h's and you're left with just 3, which is your final answer. Alright, for this example, we're going to be doing a quadratic function in which f of x equals 2x squared minus x plus 5. And you're going to want to do the same thing as the last ones, as plug in x plus h for everywhere you see an x. So here we're going to plug in the 2x plus h quantity squared minus x plus h plus 5. Remember, this is all just f of x plus h right now. We're not doing this just yet. What you're going to do is simplify this right here, and you're going to want to make 2 of those, which is x plus h times x plus h, which is the same as x plus h squared. And then you're going to want to distribute the negative to this also, so minus x minus h, and then add on the 5. Next, you're going to want to FOIL these. First put out the 2, and this will be x squared. You're going to have a positive xh plus another positive xh, you're going to have 2xh plus your last two, which are h squared. And then close the parentheses, and then just add on the minus x minus h plus 5. From here, you're going to want to distribute the 2 to all these and have 2x squared plus 4xh plus 2h squared, and again minus x minus h plus 5. And from here, you're going to see if you can combine any like terms or cancel, but in this case we can't, so we're going to add on the next part of the formula, which is subtracting the original equation. Alright, so once you have seen that you cannot cancel anything out, you have to add on the second part of the formula, which is subtracting the original function. So here you just rewrite this first part, which is 2x squared plus 4xh plus 2h squared minus x minus h plus 5. You want to put that all in parentheses, minus your original function in parentheses, which is 2x squared minus x plus 5. And if you're doing this right every time, you should be able to cancel out this original equation every time. So here you have 2x squared minus 2x squared, so that can cancel out. And then you have a positive 5 minus a 5, so you can cancel those out. You also have a negative x plus x, which is 0, so you can cancel that. Now you're left with 4xh plus 2h squared minus h right there. You want to put this all over h. Now here, since every term in both the numerator and the denominator have an h in it, you can cancel an h out of all of them. So you can cancel off the bottom there. Since this is squared, you can only cancel 1, and for the 4xh you can cancel the h there. So now you're left with 4x plus 2h minus 1. You don't want to forget the minus 1 there. That's a common mistake that people just cancel off the h and not remember to put anything back there. So this is your final answer.
So, as a summary of what we did today, we have a few bullet points to review everything that we've covered. So first off, we have our formula, which is f of x plus h minus f of x over h. And then a few tips / common mistakes. Number one would be distribute the negative. So whenever you put the original equation back in, remember that if it's minus a 5x minus 5, for example, this has to be distributed, and that would make it a positive 5. Another mistake that is commonly made is x plus h squared. So remember, if you see that, you have to make a duplicate and then FOIL. Lastly, whenever you have your last equation over h, whenever canceling the h's, remember that this does not cancel out completely. You have to remember to put a minus 1 and over 1, even though when writing the final equation you don't have to have the over 1.